Good morning, everyone. Here's your anti-set. I will also be giving you the answers to homework 11.2, even though you will be showing me the homework in your next class. So here you're building a model of a clock tower. You want to paint the roof only. How much area does the paint need to cover? So as you're watching this video today, you should be pausing and stopping the video to draw your picture, to try the math, and see if you get the right answer. All right, so hopefully you realize that the top of this clock tower is a pyramid that has a square base. So going around on your base here, I took out just the top. It's 10 inches going around. Let's figure out the height of this pyramid. Well, from the floor all the way up to the top is 24 inches. The rectangular blue part there is 18 inches. So if I subtract the 24 minus the 18, the height of the pyramid is 6 inches. So let's put that on our picture. We also know that from the right angle to the edge of the square base is half of the 10, so that would give us 5 inches. So if I wanted to find the area of how much paint would be needed for the 4 triangles that are forming the pyramid, I need to get that green line, which is the hypotenuse of this right triangle in the pyramid. So let's go ahead and use our Pythagorean theorem to find that value. And now we're going to substitute in all the information. All right, so when I plug in my 5, my 6, and my unknown, and I start solving it, I get the square root of 61, which is approximately 7.8 inches. Now I have 4 triangles on this square pyramid. The base is 10. The height that I just figured out here is 7.8 inches. So now we all know that the area of a triangle is base times height divided in half. And when I go ahead and multiply and divide, and then I know that I have 4 triangles, so I'm going to take that area and multiply it 4 times. So the total area, or how much paint I would need for this top of the clock tower, is 156 inches squared of paint. Okay, here are the answers to the homework from section 11.2. So take a look at your answers and see if you have the same things. I'll be checking your homework next class. There will be homework for tomorrow also. All right, so today's objective, this is ELR 11.3, is to find the surface area of pyramids and cones. We'll learn a shortcut compared to the way that we did it in the warm-up. Here is your homework. That's due next class from 11.3. We'll also be having an open note quiz, so you'll be able to use your notes on these current ELRs from Chapter 11. And our Chapter 11 tests will be on the Thursday, Friday of that should say the 11th and 12th. That should say the 12th and the 13th. Okay, here is the beginning of your 11.3 notes. So here are all the parts of a pyramid. I suggest pausing this video, maybe sketching one of the 2 as best as you can. Probably the square pyramid is the easiest. Knowing that a pyramid has not only a base, it has the triangles being formed to make the height of the pyramid. And there is a height in the pyramid that goes up to the top vertex point. There is something called a slant height, which is over here, which is labeled as L. So on each of those triangles that make the tower of the pyramid, there's a slant height. We have something called a lateral edge, a lateral face, as long as a base and a base edge. All right, in your notebook now, I'd like you to sketch what would a net of a square pyramid look like? What would it look like if I was to open up this pyramid? Go ahead and sketch one, and then we'll go on to the next slide. Okay, so here's my rendition of a net of a square pyramid. I have the square on the bottom, and I labeled all the sides S's. I have my 4 triangles opened up, and I labeled the slant height on each of them as L. So now what I'd like you to think about is, how would I find the area the lateral area, which would be the 4 triangles, and what would be the total surface area of this pyramid. So pause the video, see if you can figure out what it would be for both. All right, so hopefully you figured out what the lateral area and total surface area would be for a pyramid. So here the lateral area is 1/2 times the perimeter of the base times the slant height. So this P here is the perimeter of the base. The base could change because we don't necessarily have to have a square as a base on a pyramid. So that's 1/2 times P times L. The total surface area would be the lateral area, 1/2 PL, plus B. And B depends on what your base is. So I'm going to put here, as with an arrow, it's the area of the base. So the base could be a polygon, it could be a square, so many different types of bases, the area of the base. So these are the 2 formulas that you should definitely have for your surface area for a pyramid. All right, here's our first example that you would put in your notes. Here we have a hexagonal pyramid. So the base is a hexagon. We want to find the total surface area and round it to the hundredths place. So we need to find our lateral area and add the area of the base. All right, so I wrote down my formula. I am now plugging in what I need. So it's 1/2 times the perimeter of the base. It's 6 all around, and we have 6 sides because it's a hexagon. And they gave us the slant height as 9. I'm also going to be adding onto it the area of this base. Now this base is a hexagon. So do you all remember the area for a hexagon? It's 1/2 times the apothem times the perimeter. And I believe they do give us the apothem. So I'm going to plug in 1/2 times the apothem, which is 3 square root of 3, times it by the perimeter of this hexagon again, which is 6 times 6. All right, so now let's simplify this stuff that I have here. Okay, when I work it out and simplify and multiply, I get it to be about 255.53 inches squared is the area of this hexagonal pyramid. Okay, in the next example, we have a square pyramid from Italy. We want to find the lateral area. Now it doesn't say it, this is a square pyramid base. So if I wanted to find the lateral area, I would need to figure out the perimeter times it by the slant height, the L. What's missing from this is the slant height. Here it is right here. How am I going to figure out the slant height? Well, if you notice, we have a right triangle again inside. I can use my Pythagorean theorem to get what L is. So pause the video, figure out what would be the value from A to C. We have BC as 36.4. Plug in that information in the Pythagorean theorem and approximate to the 10th place what would be the slant height. All right, so when I plugged in my 15, that was the length from A to C, half of the 30. My 36.4 squared for B, I'm looking for the L squared, which is the C in the Pythagorean theorem. I square and add them up, square root both sides. I get my slant height to be about 39.37 meters. Now let's go ahead and plug it in the lateral area formula. So 1/2, the perimeter would be 30 times 4, which is 120 meters, timesing it by that slant height, 39.37. When I plug it into the calculator, divide it in half, I get the lateral area to be about 2,362.2 meters squared. Okay, moving on to the next part of this ELR is finding the surface area of a cone. I want you to think about if you actually had a cone and opened it up to see what the what the net would look like for a cone. Take a look at this picture here from the book. It's very similar to a triangle. Okay, so in your notes, definitely pause this one. You're writing down the formula for the lateral and surface area for a cone. So the lateral area is taking 1/2 times the base times the height. We got it to be pi RL. We got to consider the area, which is the circumference of the base, with that slant height, which is the height. The total surface area for a cone is taking my pi RL and adding on to it the area of the base, which is pi R squared. So I'm adding that. This is what you should put in your notes for the surface area for a cone. Now it's pi RL, lateral area, plus the area of the base, which is never going to change. It will always be a circle, plus pi R squared. So here's an example of a funnel that maybe you would use in chemistry class. They want to know how much filter paper do you need to line the inside of the funnel. Well, we need the opening to be open on the top, so that means we're looking for lateral area. I need to figure out what the radius is and what the L is. So the radius, obviously, looks like it's going to be half of the 80. So the radius here is 40 millimeters. I have no clue what the L is, the slant height, but again, we have a right triangle, so we will be using Pythagorean again to find the slant height. So pause the video, plug in your two legs to find the L. Okay, when I plug in 40 squared plus 45 squared to equal that slant height squared, I get it to be about 60.2 millimeters for the slant height. So now if I use my lateral area formula, pi times R times L, I'm plugging in my radius of 40. My slant height that I just got is 60.2. Plug it in, and I get it to be about 8,510 point, says to the hundredths place, 57 millimeters squared. So this is the lateral area of this funnel, how much paper we would need to line it. All right, here's our last example for the whole lesson. Here we have a cone. They want to know what's the surface area of the cone in terms of pi. So we want to keep our pi in the answer. So our surface area formula says pi RL plus pi R squared. We have the slant height and the R, so we're just plugging in all the information that we have. Okay, so when we plug in our radius and our slant height, I multiply, I get 375 pi plus 225 pi. I add those two numbers together, and I get it to be 600 pi centimeters squared for the surface area of the cone in terms of pi. Okay, so this is the end of our lesson on 11.3. My suggestion is you could look at the notes also that I have online besides the PowerPoint. Try your best with the homework for 11.3. Again, here's the homework that's due for next class from 11.3. And then I'll see you next time.